This lesson is solving mixture problems and uniform motion problems, and these are very, very difficult, so I'll try to go slowly in the video. Remember to watch it as many times as you need to, and I will set up all of your tables for you for your assignment. I'll give you a sheet that has them all set up ready to go. I'm going to be that nice to you because this is very, very difficult. Now, I want to talk about a weighted average first. Baseball players' performance is measured in large by statistics, and a slugging average is a weighted average. That means the power of the hitter. So it is not simply just, all of the hitting stats added and then divided. What they do is they take their first at bat, multiply the second at bat times 2, third at bat times 3, fourth at bat. If they get a home run, they're going to have a higher chance than if they're one at bat. So that's one example where we use a weighted average. Another example would be in ice skating for the Olympics. Each round that you have counts for a certain score, but some of the rounds are worth more than other rounds, and that's a weighted average. So we'll be working with that a little bit today. So weighted average is the sum of the product of the number of units and the value per unit divided by the sum of the number of units represented by M. A mixture problem is problems in which two or more parts are combined to form a whole. And uniform motion problems or rate problems are problems in which an object moves at a certain speed or rate. Both of these vocabulary words have the same definition. They're the same type of problem. So let's start with this problem. It's called retail. A tea company sells blended tea for $25 per pound. So as you can see, I have a table set up. I already told you my let statement. I want let W be the weight of black tea, and I'll show you where I got that in a moment. And in this column, I have the pounds. In this column, I have the price per pound, and here I have the total price. So I already know that I'm going to sell this at $25 per pound, so I know I'm going to put 25 on the table somewhere. I want to make blackberry tea. Dried blackberries cost $10.50 per pound. So here's the dried blackberries. They're $10.50 per pound, and they're blended with black tea that costs $35 per pound. So I've got the price per pound there. And I want to know how many pounds of black tea should be added to 5 pounds of dried blackberries to make blackberry tea. So my let statement here comes from the question, how many pounds of black tea? There it is, pounds of black tea. That's going to be my let statement. That's going to be my variable W. So I'm going to go here to my table and I'm going to see black tea pounds and I'm going to put a W. Okay? Now, let's fill in what else we know from the problem. We know that the blended is $25 per pound. We know that the dried blackberries are $10.50 per pound. And we know that the black tea is $35 per pound. And I don't worry about units here. I just have the numbers there because I can put the dollars up here and I don't have to worry about that. Now, I know I want to have 5 pounds of dried blackberries. And so all I need to do now to fill out my table is fill out here and the totals. Well, think about this. What would the total be if I have 5 pounds of dried blackberries and W pounds of black tea? Well, it would be 5 plus W because it's a mixture. I'm putting them together. Now we'll go to the totals. I take 5 times 10.50 and that gives us what value here? 52.50, and you can check my math if you need to. 35 times W. And then I'm actually going to distribute this. Here's what it would look like not distributed. See, I take 25 times 5 plus W. But I'm going to go ahead and distribute this, and I'll put it just below it so that we have everything simplified ready to put together in an equation. So this is going to be 125 plus 25W. So here's our equation now. I'm going to take this total of the dried blackberries, and I'm going to add this total of the black tea to get this total of the blackberry tea. Can you look at that and see where it came from? Just this column. This column is what sets up our equation, and that'll happen on all of our problems that we do for homework, everyone. This column sets up our equation. So now our goal is to solve for W. And it really doesn't matter which way you go. I have 35 here, 25 here, so I'm going to start by subtracting the 25 because I like to stay positive. You guys know that. So I have 52.50 plus 10W is equal to 125. Now I need to get this number over here so that I can get my W's by itself. So I subtract 52.50 and I get 10W is equal to 125 minus 5250, which is 7250. And then I divide by 10 so that I can get W by itself, and W is equal to 7.25. So I go back to my let statement. My W is the weight of black tea, so I could say 7.25 pounds, or you could say 7 1/4 pounds, whatever you prefer. So that is a mixture problem. You'll do an example in your notes now. Now we have a mixture problem that deals with percents, and this will be example 2 in your notes. Mindy has 16 cups of fruit punch that is 3% pineapple juice. She also has a punch that is 33% pineapple juice. How many cups of this juice would she need to add to the 3% juice to obtain a 20% solution? So my let statement is my question. How many cups of the 33%? There it is. The amount of the 33% is going to be my X. You'll notice this table is a little bit different. Here are my percentages, here is how much in milliliters, and then here is my total. Okay, my labels are wrong here, don't worry about those labels, but this is total, and this is going to be cups. Sorry about my labels there. So this is the percentage, this is my amount of cups, and then this is my total. So we go back up here, I have 16 cups of a 3% juice. So guess what this solution would be? 16 plus X. Now, to find what my total would be, I use my percents. Find 3% of 16. Just take 3% times 16. That would be 0.48. 33% of X is 0.33X. And then this 20% of punch would actually be this, but we have to distribute it, multiply it out. And when you distribute it, you get 3.2 plus 0.2x. So now our total column is going to be our equation. So I have 0.48 plus 0.33x to equal this total punch solution. My goal is to solve for x. This is actually more than this, so I'm going to subtract my 0.2x. I get 0.48 plus 3.2. I'm just going to check that, make sure I have that right so far. And then what I'm going to do now is subtract this 0.48, subtract this 0.48. Think of it like money. This is $3.28, or 20 cents minus 48 cents, if that helps you, if you're struggling with the decimals at all. 2.72 is what I get when I type that into my calculator. And then to get x by itself, I divide by 0.13. So x is equal to, when I get that divided, 20.9. So I go back up here to see what my let statement is. My let statement is going to be how many cups of the 33% solution. So how many cups here of the 33% solution? 20.9. Now, a uniform motion problem is going to use the distance equals rate times time. And so you can create a table, and I'll show you an example of that on the next example where we have distance, rate, time. Or you could have something like this. It took Lauren and Taylor 40 minutes to skate 5 miles. So what we're going to do is find their rate for going. And that's going to be distance, which is 5 miles, divided by the time, which is 40 minutes. So you're going to get a rate in miles per minute there. And then the return trip, it's still 5 miles. Still 5 miles. And this time it took them 30 minutes. Now, I want to know average speed. Well, average speed, we don't use miles per minute. We use miles per hour. So what I would recommend is to figure out how much of an hour this is. So you can do a ratio with 40 divided by 60. Same thing here, do 30 divided by 60 because 60 minutes are in an hour, and that's how much of an hour we're going to use. So on the going trip, we have 5 divided by about 0.6 repeating. And on the return trip, we have 5 divided by 0.5. So our going rate is going to be about 7.5 miles per hour, and our return rate is going to be about 10 miles per hour. So to find their average speed, what we're going to do is we're going to find the average together. So we're going to take this rate, because average speed is miles per hour, we're going to take this rate, which is the 7.5, and we're going to multiply that by, because we're taking the rate of going times that time that we were going there. So that's that 0.6 repeating. And then we're going to take and add this distance and rate, this rate, and this time here was 0.5. And we're going to divide this amount, this is a weighted average, we're going to divide it by this rate, this right here, this time it took, plus this time it took, so we have a total time on the bottom. And when you add that and multiply, you get about 10.0025 divided by 1.167 approximately when you add those. And the last thing you do is divide, and you get 8.6 miles per hour. So you're going to find a going rate, returning rate, and if you want to keep this in your notes, you are going to have a problem similar to that with a weighted average with distance, rate, and time. Another example of a distance, rate, and time is when you have two objects. I have two trains that are 550 miles apart heading toward each other on parallel tracks. And train A is traveling east at 35 miles per hour. Train B is traveling west at 45 miles per hour. And I want to know, when will they be equal to each other? Same place, same time. When will they pass one another? That's equal. So train A has, this is a distance equals rate time table. Here's where I'm going to put rate, here's time, here's my distance is equal to rate times time. And I'm going to let T be the number of hours until the trains pass each other. And here's the thing about distance, rate, and time problems. The time is going to be the same for both objects. One starting here, one starting here. The time is going to be the same for them to pass each other because time is relative. So it's going to be T for both. Now you are going to have some problems where one person leaves at a certain time and another one leaves later. Well, then they would have a different time. One would be first, one would be later. So the train A rate is 35 miles per hour. The train B rate is 45 miles per hour. So when I do their distance multiplication, I get 35t and I get 45t. Now in this case, we have that set up. We have a common distance, which is right here. So we are going to do 35t plus 45t. When will they be 550 miles apart from each other? Remember, their time is the same. So we add these two, and what is that, 80t? And then we would want to get t by itself, so we divide by 80. And we get t is equal to 6.875. Now t is the time it would take for them to cross each other, and it's in hours. So it would take 6.875 hours until they would pass each other. And then I'll give you a table problem with distance, rate, and time in your notes to practice.